45 minutes. Okay, until 1 o'clock. Right. For 3.2, revision last week. Blood circulatory system in vertebrate. We have 4 group of animals, including human. We have fish, got 1 atrium, 1 ventricle. Amphibian, 1 ventricle, 2 atrium. Reptiles, same with amphibian, 2 atrium, 1 ventricle. And human, including mammals and birds, have 2 atrium, 2 atria, and 2 ventricles. Okay. And then we learn about the structure of heart. Okay, we have artery, heart connected with artery. It's your real heart, artery and vein, and also we have blood capillary in between artery and vein. In the function of the human heart, of course, to pump blood to whole of our body, but we have different type of blood vessel. We have 4 blood vessels: vena cava, pulmonary vein, aorta, and pulmonary artery. Okay, still remember the structure that I drew at the whiteboard last week? I drew the heart. Okay. Okay, our heart have 4 chamber: atrium, right atrium, right ventricle, left atrium, left ventricle. Okay, consists of 4: VC, aorta, PA, and PV. Still remember this one, Okay, this diagram is quite complicated. Okay. I love to use this. Okay, this one. Quite simple. Simpler than the other one. Also, this one we can you can see the flow of blood from the whole body here. Okay, from the whole body enter the right atrium, right ventricle, and then come out from pulmonary artery to the lungs. Okay, from the lungs, oxygenated blood bring to the pulmonary vein, enter left atrium, left ventricle, and come out from aorta through semilunar valve. Okay, 3 type of valve: tricuspid valve at the right side, bicuspid valve at the left side, and 2 semilunar valve in between the atrium and ventricle. Between the artery and ventricle. Between artery and ventricle, we have semilunar valve. Okay, between atrium and ventricle, left and right side, we have tricuspid and bicuspid. Okay. The function of valve is to allow blood flow in one direction only. Okay. So we have tri. Tri means 3 flap. Okay. Bicuspid, bi means 2 flap. Okay, now for today, we go to the comparison between vein, artery, and capillary. Okay. If you look at the diagram here, the table here, table 3.1, we have 3 different structure. Okay, this is the valve, the flap here. Vein got valve. Okay, vein. It has a bigger lumen, Okay, from the front view or upper view, the vein have bigger lumen. And a thinner wall compared to artery. Okay. The blood flows through the lumen. That's the lumen. Okay. And for artery, okay, it has thicker wall and small lumen. artery has thicker wall because it needs to stand higher pressure, and it has a small lumen, smaller lumen than vein. Right. Now, capillary, as you know, capillary is formed by one thick cell only. Or one cell thick. One cell thick. One cell thick. Then connection between vein and artery to bring the both oxygenated and deoxygenated blood from the alveolus to the heart, from the heart to the alveolus or to the lungs. Okay. All right. The main function of vein is to transport deoxygenated blood. We have a vena cava, that transport the deoxygenated blood from the whole body. Okay, and then it come out from pulmonary artery, go to the lungs to take oxygen, transport oxygen. Okay, circulation of blood is slow, slow blood flow under low blood pressure. Okay, slow blood flow compared to artery. Okay, for artery, this artery we refer to the aorta. It has thick and muscular wall. Thick and muscular wall with a lot of elastic tissues to withstand the high blood pressure. And it has small lumen, and the function is to transport oxygenated blood. Transport oxygenated blood from heart to the whole body. Okay. Meanwhile, pulmonary artery, what I mentioned before, pulmonary artery is also artery, but pulmonary artery transport deoxygenated blood. This one, pulmonary artery, even it is artery, it transport deoxygenated blood together with vena cava. Okay. One more, pulmonary vein. Okay, pulmonary vein transport oxygenated blood. Even its vein. Vein, the main function is transport deoxygenated blood. But here, pulmonary vein, even it is vein, it transport oxygenated blood together with aorta. So be careful here, don't be confused. The main function of vein, especially vena cava, is to transport deoxygenated blood except pulmonary vein. For artery, the main function of artery, siapa nak masuk? KX Wong. Okay, for artery, the main function for artery is to transport oxygenated blood, blood that contain more oxygen from heart to the whole body, except pulmonary artery. Okay. Vena cava, aorta, dia punya main function for vein and artery. And then the rest, pulmonary vein bring oxygenated blood. Pulmonary artery, deoxygenated blood. Even its artery, it bring deoxygenated. Any question? Kana? Okay. Right. Human have double blood circulatory system. Why we call it double? Okay, double blood circulatory system. Okay, why double? Because we have two type of system, pulmonary circulatory system and systemic circulatory system. Two system. Okay, pulmonary. Pulmonary involve pulmonary artery and also pulmonary vein. Okay, so pulmonary artery take the blood from heart. Okay, still remember, pulmonary artery take the blood from heart to the lungs. Okay, transport the deoxygenated deoxy to the lung to get oxygen. So at the lungs, exchange of gases occur. Okay, then the blood gain the oxygen. Okay, transport back by pulmonary vein to the heart, return to the heart again. So we'll call this pulmonary circulatory system. The one who involves pulmonary artery and pulmonary vein is called pulmonary circulatory system. To get the oxygen from lungs and return back to heart. Okay, the other one, systemic circulatory system. It involves artery. Involves artery means here is aorta. So this artery here is aorta. And vein is pulmonary vein. Vein. Wait. This one is vena cava. Sorry, vena cava. Vena cava. Because both both aorta and vena cava, it transport blood. Dah. Ni. Anak saya. Okay. What? Okay, for systemic circulatory system, involve aorta and vena cava. Vena cava take the blood, transport the blood from the whole part of body enter the heart. Okay, and then from the heart, aorta pump the blood to whole part of the body. So for systemic circulatory system, involve all part or the whole body, whole body. Systemic circulatory system. Pulmonary circulatory, pulmonary artery and pulmonary vein to the lungs, and from lungs to the heart. Systemic circulatory system from aorta to whole body, which is this one is oxygenated blood. Kalau from aorta, the blood is oxygenated blood. From the whole body to vein, which is vena cava, this one is deoxy. Okay, why deoxy? Because when the heart pump blood to the whole body, so it reach the blood cell. Okay. When it reach the blood cell, in every part of your body, the blood cell will take the oxygen. The oxygen will diffuse into the blood cell to carry out cellular respiration. Okay, for you to do the activity. So from the blood cell, at the same time, carbon dioxide will diffuse into blood capillary. So from the blood cell back to the vena cava, to the heart, it brings the oxygenated blood from the body cell, not blood cell, body cell. To the body cell. From heart through the aorta pump up to the whole body. That is oxygenated blood, contain more oxygen, okay, to the whole body. Once it's reached your certain part of your body, every part of your body, okay, it diffuse the oxygen to the body cell. Body cell taking oxygen and diffuse carbon dioxide. Diffuse carbon dioxide, replace the oxygen in the red blood cell. So from whole body back to the heart through vena cava, it brings the oxygenated blood. Okay. And this one? Right. Got two. That's why we have double system. Pulmonary and systemic circulatory system. A double blood circulatory system. Okay, now we go to the heartbeat and pulse rate. Okay, heartbeat. Okay, when the doctor use the stethoscope to hear the sound of your heart, you can hear the lap-dap sound. Have you ever heard the lap-dap sound produced by a beating heart? Okay, we only can hear using a stethoscope. We use stethoscope to detect your heartbeat. To hear the beating of your heart. Okay. Between the lap and dub sound, which is louder? And how is the lap dub sound produced? Okay. Ini nak kena rotan ni. Okay, heartbeat. Heartbeat, you need to know where's the production of lap dub sound and the reading of the heartbeat. How we measure the heartbeat. Alright, if you look at two diagram here, okay, we have diastole and systole. Okay, diastole refer to the condition of our heart when it relax. So diastole will produce dub sound. Now you just remember dub D, same with D diastole. Diastole produce dub sound, means that the sound of dub is produced when our heart is relaxed. The condition of heart is relaxed. Okay, when your heart is relaxed, the diastole reading will be formed on the sphygmomanometer. We have an instrument to measure the blood pressure that we call it sphygmomanometer. Okay. The second one is systole. Okay, systole produce lap sound. Lap sound, which means that our heart is in contract, or when the our palm is pumping the blood out. Okay, you see the white arrow here. The heart is pumping out blood, so it contract and it produce lap sound. So this lap sound is quite louder than dub, because dub, your heart is relaxed. Okay. Siapa baru masuk ni? Yiching. Hi. Okay. So now from diastole and systole, we have two types of reading. Diastolic pressure reading and systolic pressure reading. Okay. Remember, diastole produce dub sound. D, dub. Diastole, dub. Systole, lap. Lap, dub. Okay, your heart is sound lap, dub. Like that. When we use a stethoscope. Okay. To measure your blood pressure, your heartbeat, we use this one. This A, sphygmomanometer. Yes, sphygmomanometer. SPHYG, sphygmomanometer. Okay. Using the mercury inside it. We have mercury inside this scale. And together used with the stethoscope. A and B. A is a sphygmomanometer. B is stethoscope. Okay. Pada medical practitioner, dia akan guna both sphygmomanometer and also with the stethoscope to measure your heartbeat. Okay, our normal reading is 120 over 80 millimeters of mercury. Okay, 120 or here state over 70 or 80 millimeters of mercury, normal reading of human heartbeat. Okay, so from this reading, 120 over 70, okay, we follow your textbook here. Okay, millimeters of mercury. Millimeters of mercury is the unit used to measure the blood pressure. Millimeter is the unit for length. The length that we get from the scale of the sphygmomanometer here. From the picture here, okay, we calculate the length. The length of the mercury rise inside the column. The column of mercury. So length. Mercury, length of mercury, millimeters of mercury. Hg refer to mercury, symbol in chemistry. So here we have two readings, top and bottom. Okay, the top reading refer to the systolic, systolic reading. Okay, top is systolic. I write again, systolic blood pressure reading. The bottom reading, bottom measurement is refer to the diastolic blood pressure reading. Diastolic blood pressure reading. Okay, still remember systole or systolic when your heart is pumping or contract. Diastolic when your heart is relaxed or in between your heartbeat. Diastolic. We have two types of reading: systolic blood pressure reading and diastolic blood pressure reading. Okay, for this one, measurement of blood pressure. Okay, if you have a reading more than this, more than 130, more than 130 means that you have high risk of high blood pressure, may lead to heart attack. If lower than this, you may get low blood pressure, easy to faint, dizzy, unconscious, lower blood pressure. Okay, now next, pulse rate. Okay, this one two type of instrument to measure your heartbeat. Number one is sphygmomanometer with the stethoscope. We usually use both of these in clinic or hospital. Use both. Okay. One more is digital sphygmomanometer. The second one is digital sphygmomanometer. This one is more portable. You can buy at the pharmacy. That count the number. Digital number. So we call it digital sphygmomanometer. This one no need to use with stethoscope. Okay. For the classic one, this is the classic one. Sphygmomanometer only. We use it with stethoscope. Okay. Okay, pulse rate. Alright. Pulse rate. This one, this topic continue until Form 4. Same topic. Form 4, Chapter 3. You take heart. Okay. You will learn again measurement of blood pressure. The same one. Okay. Right, pulse. How to measure your pulse? What is pulse? Pulse is the contraction and relaxation of the muscular artery wall. When your artery inside your heart contract or relax. Okay. Pulse is produced when the contraction and relaxation of muscular artery wall. Okay. We measure pulse rate in 1 minute or 60 seconds. Okay. How to measure it? Put your finger at the pulse point. Pulse point. Okay, here your wrist. Your wrist has a radial pulse point. Radial pulse point. Titik nadi. So we measure it here, and one more carotid pulse point, which is at your neck. At your neck. Use two finger detect your pulse point at your neck. There's carotid pulse point. One more at your wrist. Find out the contraction of your heart, muscular heart. Okay. Next, the factors that affect the pulse rate. Okay, this one should be the activity or experiment. Experiment 3.1 in chapter 3. The first experiment in chapter 3 to determine the factors that affect the pulse rate. Is it age affect the pulse rate or your health? If you are sick, is it affect your pulse rate? Is it pulse rate increase or decrease? Okay. Third factor is your activity. What is your measurement of your pulse rate if you are resting or walking or running? So we need to identify, investigate. And then the next factor is gender or sex, female or male. Which one is higher pulse rate? Which one is lower pulse rate? Okay. Right. For the first one, for the activity, okay. Let's say we have we do this activity the same age, same age. We fix the age summer. Okay. Let's say the whole class is now you are 15, right? 15 years old. Okay, we fix the age. We just measure the activity, type of activity. Manipulated variable is activity. The same person running, resting, first resting, and after that for 2 minutes walking slowly, and then another 2 minutes it running. So there are 3 activities here. Okay, resting, walking, and running. And for each activity, you take the number of your pulse rate, number of pulse per minute, and then we see what happened. Okay, follow with other student, second student, third student. This one you can do individually lah. Do it yourself. Okay, do individually. So we will see what happened. Okay, after 10 seconds and after 60 seconds in 1 minute per minute. So 60 seconds. Okay. So from the activity here, we know, we already know running will produce higher number of pulse rate. Higher number of pulse rate running. Okay, if you do jumping, okay, after running you do jumping, so the number of pulse rate also will increase. Will increase. For each vigorous activity that you have carried out, the number of pulse rate will increase. Okay. Now, other factors that influence the pulse rate, we have gender. Okay, gender refer to male or female. Okay. Female actually has higher pulse rate compared to male. Male has lower pulse rate. Okay, I use a symbol of arrow. This one means higher. Okay. This one, inverted arrow, upside down arrow is for lower. Okay, saya akan selalu guna simbol higher atau lower, guna arrow. So male has lower pulse rate, female has higher pulse rate. Why? Okay, because of the size of female heart is smaller than male heart. Size of the heart of female, okay, heart of female smaller, smaller size, smaller than male. So it need to pump blood faster, okay, compared to male. Same goes to children. Okay, that one is age lah. Okay, for age, different age. For children, for baby, it is normal. If the baby or children has higher pulse rate rather than normal. Okay, because of the age, because of the size of their heart. Okay, baby got smaller heart, so you need to pump blood faster. To transport the oxygen to the whole body, you need to pump faster. What's that? Will the machine test chun-chun what? Yu Hong, apa tu chun-chun?
I mean the machine, the one, the blood pressure machine, is it very, how to say, very, very sharp one?
Very short.
I mean very sharp, the testing.
Yes. It will produce a accurate reading.
Really can test one.
Hmm?
We really can test one.
Yes, can. You have the watch, smartwatch. Can use
Uh-huh.
smartwatch. Inside the smartwatch also got a blood pressure reading.
Okay.
Okay. Alright. For age, for age, okay, children has higher pulse rate rather than adults, and older age. Okay, for older age, 60, okay, 50 to 70 years old. The pulse rate decrease. The pulse rate are lower than adults. Lower than adults. So 50 is still higher, 170. Okay, 170. And so it's become older and older, the pulse rate are decrease, become lower. As age increase, the pulse rate decrease. Bila umur meningkat, dia punya kadar nadi akan berkurang. Age increase, pulse rate decrease. Okay. Because your heart is already lost their elasticity to pump the blood. That's why we need to take care of our eating habit so that our heart is not blocked with the cholesterol or fats. Because we are getting older and older, then the elasticity of our heart also decrease. If there's block in our heart, it may lead to heart attack. Okay. Next, the last factor, the fourth factor is body health. Okay, the pulse rate of less healthy individual means the sick person is normally higher or lower than the normal pulse rate. Can be higher or lower. Okay, so this one for the sick person, you must go to medical checkup lah to know is it higher or lower. Okay, maybe it's because of another disease. Okay, maybe got heart attack, so dia punya pulse rate will become higher. Okay, or lower than the normal pulse rate. So depends on the condition of your body. Okay, that's why bila you pergi buat blood pressure, you kena relax, kena calm. Tak boleh tiba-tiba lepas berlari you terus buat blood pressure, tak boleh. Cannot. You must calm first to make sure we will get the correct reading to determine your body health condition. Okay. Right. There's 4. Remember the factors that influence the pulse rate. Okay, here we have age. As age increase, as you become older, your pulse rate will become lower. Okay, the health condition depends on health. The pulse rate depends on health, either increase or decrease, either higher or lower, depends on the health. Okay, health condition. And then activity, vigorous activity, or if you are too active, you will get higher pulse rate. Higher pulse rate. Okay, again, gender or sex. Female has higher pulse rate rather than male because of the size of the heart. Okay.